Hey chemistry peeps, Jess McCartney here. We're back for year 12. I hope we're excited for an amazing year. Keep a lookout for lesson links. There is lots of lesson links in year 12. But first of all, we're going to look at fossil fuels. So how old are fossil fuels? So most of the fossil fuel material we use today comes from algae, bacteria, and plants, which we're going to talk more about in this lesson. Some of which date back to the Devonian period, which is about 419 million years ago. Consequently, at least most of this time, you are not pouring refined dinosaur parts into the gas tank of your vehicle. So it has been refined for you to have proper petrol and fuel that we use every day. So let's look at this in more detail. So we're looking at Area Study 1 today, and so what are the current and future options for supplying energy? And we're going to be focusing on fossil fuels in this lesson. So the study design dot points that we're going to be looking at is the definition of a fuel, and we're going to be looking at the fossil fuels, coal, natural gas, and petrol, and why these are classified as non-renewable fossil fuels. So let's look at what a fuel is. So a fuel is actually a really broad term. So a fuel is a substance with stored energy, and that's important, and we're going to look at that in the future when we start looking at equations. And this can be released relatively easy using heat or power, so the little bit of ignition that we need to start that equation. Fuels actually come in many different forms. So for example, sugar is actually classified as a fuel. It has stored energy, and this is used in biological systems, while petrol is used to meet the needs of energy and transportation in our society. When we're thinking about fuels and the uses for society, we are always looking at like petrol for the car and things like that, so that we use every day. So this is known as a local level use of fuel. When we're looking at national level, we're considering Australia's use of energy resources and if it's sustainable for us to continue to do that. Then we can look at a global level, so considering whether the use of fossil fuels is contributing to enhanced greenhouse effect and what that might then contribute in the future. These are all connected, and they contribute to the overall amount of fuel available on Earth, and this impacts its use. So when we're looking at energy, we can look at energy in all different types of units. So there is a system where chemists use units, and this is known as the International System of Units, or SI units. And this is a widely used system of measurement that specifies a range of quantities. So this is used internationally. So everywhere around the world uses these types of units, and that means it's recognized in scientific journals all around the world. So when we're looking at energy, the SI unit for energy is joules. So this is what you will see it in a lot of the time. However, 1 joule of energy is actually a really small amount. So you may sometimes see the energy used in kilojoules, which is 1,000 joules. And then depending on the type of calculation you're doing, so if you're looking at an extensive energy source, so like coal powering Australia's energy needs, you may start to see it in the bigger units of energy, so the megajoule, gigajoule, and terajoules. And this is obviously getting into the millions and hundreds of millions of joules. So where do these fossil fuels come from? Well, like mentioned earlier, these are actually decomposition reactions of buried dead organisms. So over geological time, in the absence of oxygen, heat and pressure alter the chemical structure of the organic matter in these dead organisms. And because of this, because of that intense heat and then that intense pressure, fossil fuels are formed. And these, again, are crude oil, natural gas, and coal. Now, when we're thinking about Australia, we actually have large reserves of coal and natural gas only. We have very, very limited supply of the crude oil. And you can see in this image here where these reserves are located. And there's obviously lots of other areas where there's possible locations, but this is where there are current mines, as you can see, all up in the west side. There's lots of current mines currently being developed for coal and natural gas. So coal is made from plant material, so from wood and plant material that has decomposed over millions of years. Now, what's important to note about coal is that the longer that it's left, the better energy amount it has. So if we're looking at this image here, you can see that the black coal, which is buried lower in the ground, has a heat release of 35 kilojoules per gram. So therefore, that it has the highest amount of energy over the other coals. Now, as you're going up and you're going to peat, this is 60% carbon and the energy release is less. So when we're thinking about mining for coal, we obviously want to have this black coal that we're getting because we get more energy out of it. However, as the reserves start to decrease, we are starting to pull out coal before it's becoming that black coal. So crude oil is a mixture of hydrocarbon molecules, and this is mostly alkanes. These are made from dead organisms as well, generally aquatic life, and this is why most of our crude oil rigs are found on the ocean. Crude oil itself is actually pretty useless. You can't use it for anything in its natural form. So what we need to do is we need to put it through a fractional distillation. And this is where we are using the boiling points of different alkanes and separating it and collecting it. So the crude oil is placed into a furnace, and you can see at different temperatures, the other types of fuel come out, and that is then collected. So natural gas is another fossil fuel, and this is found in deposits of Earth crust. This is generally found where other mines are found. So you can see in the diagram that the natural gas point is actually just before the crude oil collection. And that's similar across the board when we're looking at natural gas. It's pockets that is found in those mines. So it's mainly composed of methane, and there's some small amounts of ethane and propane as well. And then you have other byproducts such as water, sulfur, nitrogen, and carbon dioxide. So like stated before, that it's found in those other deposits and it's extracted via drilling. And now once the hole has been drilled into the ground, it will actually naturally migrate to the surface. It will release because it's under intense pressure. So once that pressure is, busted, that will then release the gas up to the surface that can be collected. So to summarize, remember that a fuel is a substance with stored energy. That is the best definition for it. And it can be in lots of different ways. So sugar, petrol, natural gas, and then we'll start looking at some renewable ones as well. So a fuel is considered non-renewable when it cannot be replenished at the rate it's being consumed. So because the fossil fuels take millions of years to form, we are just using that way more at a quicker rate than what that's being formed. So therefore, they're classed as non-renewable. Fossil fuels are formed from the decomposition of buried dead organisms. So this is plant and animal life. And examples of fossil fuels are coal, crude oil, and natural gas. So looking at what's coming up next, we are going to be looking at biofuels, and this is looking at the renewable sources of fuel still with that stored energy. I will see you next time. Bye-bye.